Okay, I've got a command of evidence quantitative, so I have a graph here, and we want to know which choice use data in the graph to complete the statement. So we're going to have some type of example or statement, and we want to complete that statement at the end. And we always want to find this statement that is accurate to the graph and relevant to the claim in that final statement. And let's just check the graph. I usually check the graph to see if I understand what's going on. Number of suggestions, suggestions for improving a university, additive, subtractive, or neither additive, subtractive, invalid. So I've got different types of suggestions and the number of suggestions given. Let's read the text. Gabriel Adams' colleagues reviewed suggestions for improving a university that had been submitted to the university's president. They coded each suggestion as either additive, it wanted to add something new, subtractive, take something away basically, neither of those, or invalid. The idea was just not even comprehensible. The data illustrated people's tendency to overlook the possibility of removing things to achieve improvements. And then we've got a colon, so we need an answer where people overlooked removing. In other words, they always wanted to add something new. They never thought, oh, let's take it away. So I would guess that would be supported by very few subtractive. Sure enough, subtractive is the lowest number of suggestion categories. That's our evidence. Let's find that. Around 175 suggestions were coded as no, that's not it. More than 350, no, that's a lot. That's not going to be it, right? Fewer than 100 suggestions were coded as subtractive, whereas more than 550 were coded as additive. Again, this shows people want to add things, not subtract things, and that illustrates our claim. C is going to be the right answer. Just quick check D. Around 575 were coded as additive, whereas 175 were coded as subtractive. Is that right? That's wrong. 175 were not coded as subtractive. It was less than 100 that were coded as subtractive. In fact, it looks like it was only about 70 or so. So kind of the right idea to answer the question in D, but not accurate to the graph. C is the answer. It's accurate and relevant. Okay, we need to support the researcher's claim from data in the table. Let's see what the table is, and then we're going to read it, and then we're going to check for accuracy and relevancy. So approximate rates of speech and information conveyed for 5 languages. Okay, got different languages. Rate of speech, that is syllables per second. Rate of information, bits per second. Okay, so there's a slight difference here, right? I can speak, but if I don't say a lot of information as I speak, another language might actually convey more information per second. So, all right, let's look here. What the rates that are high are Serbian and Spanish, and the information that's high is actually Spanish and Vietnamese, suggesting Vietnamese has a lot more information in the amount which you speak. So, all right, let's see the ideas here. Let's read the text. A group of researchers working Europe, Asia, Oceania conducted a study to determine how quickly different Eurasian languages are typically spoken and how much information they can effectively convey. Okay, see that in the table. They found that although languages vary widely in the speed at which they are spoken, the amount of information can effectively convey tends to vary much less. Okay, so what they're saying is the variation here basically has a standard deviation, basically, that's lower than kind of the standard deviation here, right? So greater variance here, and less so here. That true? Yeah, kind of looks like it's possibly true. We're only going up about 20%. Here we're going up more like 40 to almost 50%. All right, there seems to be some truth to that, okay? So let's see if an answer pulls that out. Among the 5 languages in the table, Thai and Hungarian have the lowest rates of speech and the lowest rates of information conveyed. Okay, that just says they're the same ratios. So that doesn't show a difference of variance between the two columns. Okay, Vietnamese conveys information at approximately the same rate as Spanish, despite being spoken at a slower rate. So this could be an example. They have very different spoken rates. Yeah. And that checks here. And nonetheless, the same amount of information. That checks. I believe this is going to be our answer. At least this example supports it. Now, is there something else that supports it more with more examples? Let's take a look. C, among the 5 languages, the language that is spoken the fastest is the language that conveys information the fastest. Okay, that just says they're kind of directly related. We want to show some reduction in the variation in information. Serbian and Spanish are spoken at approximately the same rate, but Serbian conveys information faster than Spanish. That doesn't really support our idea. We want the same information, and we want different spoken rates. That is not this. B is the answer.